Hello, and welcome to Getting Started with Mirantis Kubernetes Engine on Google Cloud Platform. Today's webinar is sponsored by Mirantis and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I am excited to be your moderator for this special event. And with all that, let's get to today's fantastic content. So it is my pleasure to introduce you to our presenters today. We have Mike Ward, who's Director of Product Marketing for Cloud Infrastructure at Mirantis, and we have Renad Singh, who's Senior Software Engineer for Mirantis Kubernetes Engine at Mirantis. So with that, I'm going to turn things over to Mike. Mike, great to have you here. Take it away.
Thanks, Scott. I want to welcome everyone today and thank you for joining us to talk about the choices around cloud providers and also how to leverage a Mirantis Kubernetes engine on top of the Google Cloud Platform. We're going to talk about a number of topics today, and the first of which is why you need to avoid cloud provider lock-in and the challenges that come along with that. We'll also then talk about the power of choice. Choice from a number of vectors that we'll dive into more deeply as we go through the content today. And then we'll hand it over to my colleague to show you how you can actually get started with Mirantis Kubernetes Engine on Google Cloud Platform. And he'll actually show a demo of installing MKE on top of Google Cloud and show you how you can take benefit of that as one of a number of choices for running your container-based workloads using Kubernetes in the cloud. And then we'll wrap up with some Q&A and get your input and questions from that point. So I'm sure everyone has heard the old saying, do you want to put all your eggs in one basket or don't put all your eggs in one basket, right? And as we apply that saying to cloud computing and the public cloud in particular, there are a number of factors to consider here. The first is that of service outages. If you're running on one specific cloud provider and they have a large-scale outage, that can be very disruptive to your business, both in terms of ability for users to access the services, and of course, lost revenues that come along in the way, and then concerns on how quickly can you get your applications back up and running and get your services restored. There's also the factor of geographic access. One of the important things, and increasingly important with applications, is are you able to place portions of your cloud native workloads as close as possible to your users to reduce latency and to ensure that they have timely and quick access and responsive access. Certain cloud providers serve certain geographic regions more strongly than others. So this is one reason why you may want to look at the ability to have multiple providers to be able to position your services close to your particular users, or maybe even open up new revenues and new routes to market, new service opportunities for you to reach new customers. The next area to consider is that of platform access. Does the cloud provider of choice have the necessary infrastructure that you need for your applications today, or where you may be going tomorrow? Do you have some AI ML workloads that are going to require a specific type of GPU service, and does your current cloud provider provide that? Or do you need to mix and match offerings across providers to really give you the diversity of the hardware and platform access? There's also the concern of portability of your applications. We'll talk a lot more about this as we go through the discussion today, but fundamentally, ensuring you have providers that enable services or partners that enable services that provide you the ability to easily move applications and run applications across multiple platforms. And then finally, in this respect, we want to talk about the issues of commercial and regulatory concerns. I'll first touch on regulatory, and largely if we think about issues such as GDPR, where there's a need to protect user data, and in certain cases, the need to keep user data in the country of origin. Does your particular cloud provider have services in that region? Or maybe you actually need to keep that data on-prem, but you want to be able to do other processing in the cloud or in across other regions. So this is one reason why you want to have a multi-cloud and maybe a hybrid cloud approach, where you can really protect and ensure the integrity of certain data within your private cloud, and take advantage of public cloud services for other aspects of your compute needs. Then there's also finally kind of the concern around commercial factors. If you have all your compute services with one particular public cloud provider, are you going to be able to drive and have the best commercial negotiating power? We know cost is clearly a concern these days, even now more than ever, and making sure that you have the ability to negotiate with your cloud providers or multiple cloud providers to get the best rates is an area of utmost importance. So we know we want to have options, right? And that's going to be a core theme of the discussion today is options and choice. And you want the flexibility to run your applications on multiple cloud environments. And the great thing is there's a lot of good choices out there today. There's Amazon AWS, Microsoft Azure, Google Cloud Platform, that all provide public cloud hosting options. Then there's also services such as Equinix Metal, which provides a bare metal hosted service that provides you the ability to deploy your workloads on bare metal environments across multiple data centers worldwide. And of course, we certainly don't want to forget on-prem. The days of on-prem are not certainly by no means dead. We actually see increasing number of customers looking at perhaps pulling back some of their workloads and repatriating some functionality from the public cloud back on-prem, whether that be for issues such as GDPR and data security and sovereignty type issues, or just overall cost management. The cloud can be great when you're in a unknown state, rapidly growing company, or deploying new applications and need the ability to move very quickly and spin up infrastructure quickly. But as your applications become more mature and you understand the profile of your needs, perhaps you don't need to be paying for that flexibility, and running those things on-prem is actually a good option. I think what we believe is that there's going to be a strong need for a hybrid model across the board, where customers will be running portions of their workload on-prem and then portions of those in the cloud. So you certainly want to make sure you're not getting stuck in both your application and your infrastructure development, getting stuck with one particular vendor's option. You want to have the freedom to change cloud services as appropriate as your business evolves and market environments change. So containers is certainly the direction the industry as a whole has been going to deliver cloud native workloads, and Kubernetes as an orchestrator has become almost the de facto choice for how you manage and deploy in your container environments. As we talk to customers that are deploying these within, whether it be on-prem or in the public cloud, as we talk to customers and other users across the industry, we kind of hear a number of common themes. And I'm going to separate these into the concerns of the operators and then the concerns from the developer side. One of the concerns from the operators we hear is that Kubernetes is just part of the platform. So much focus seems to be paid these days around Kubernetes, and it's a great tool, a great way to manage, orchestrate, and ensure the availability of your container-based environments. But it's really just one piece of many that come together. There are many other pieces needed to make a real solution work. Issues of identity management, security, monitoring, how do you manage your networking, your ingress, encryption. All these factors have to come together to really make a holistic system and infrastructure deployment. And integrating all these pieces is not trivial. Kubernetes itself is incredibly complex, right? And then we add all these other pieces and making sure they work together. And as versions are changing, how can you keep up, making sure you've got the latest security patches and latest versions, and that everything's going to work together, and you don't upgrade one piece and bring down your overall environment, breaking your applications for your infrastructure. And then there's the factor of unbounded cost that's constantly a concern. Again, this is perhaps largely around the public cloud domain, as many times companies have a hard time really getting a grasp around what is their actual cloud spend or what is it going to be. So all factors that keep the infrastructure or the operator side of the team up at night. Now, on the developer side, they have similar but different issues and concerns as well. From their side, they're worried about building the greatest applications as quickly as possible to serve their customer needs. How can they? They're worried about the ability to develop those applications so they can be easily moved across the ultimate target environment, whichever cloud infrastructure that may be, on-prem, public cloud, or other environments. They're looking for optimized and seamless workflows, making their lives simpler. And I think that's a core tenet, theme that really plays around the development world is how do they make their lives simpler? They need cohesive and consistent monitoring and logging capabilities so that when something's not working correctly with their application, they know how to find those problems. And in a multi-cloud environment, the ability to have that visibility into the infrastructure, that observability has just become incredibly more complex than ever before. So needing a easy way to know what's happening is critical for them. Security is something that I don't think you'll get any argument is important and something that developers know they have to focus on, but it is also something that they're worried about not getting in their way. Again, their goal is to move fast, develop great applications, and solve customer needs. It needs to be done in a secure way, but they also they want to avoid getting bogged down by so many hoops and barriers to moving forward. And then really the last one I'll touch on here is just today, the cloud native environment for developers oftentimes is viewed as just too complex. Again, we'll come back to the concept. Kubernetes is great, but it's a very complex entity. And the developers just want to write code and build and deliver code. They don't want to be really worrying about how to manage the infrastructure. So how, if there are ways that we can help simplify that for the developer, it's a win for them. So when we look at what makes a good Kubernetes platform, a number of really 5 key tenets that I'm going to touch on here today. The first is one that provides fast time to production. And this really is addressing from both the infrastructure operations team, but also the developers. The developers need the ability to quickly spin up containers, spin up pods in Kubernetes that they can build their applications and build and test and validate their applications. And then likewise, the operations team need to be able to, quickly bring up, manage, and deploy those applications. So having an environment that allows you to do that on your choice of platform is very critical. Security goes without saying is a must-have. It's important to have a platform that provides you with continuous compliance, the ability to scan your workloads for known vulnerabilities, the ability to have those workloads validated against approved list internally, and have a mechanism of software development pipeline, if you will, where only approved software is actually being able to be pushed out to deployment or situations of those nature. And then finally, having built into the platform security certifications, things such as FIPS 140.2, which is related to just the overall encryption technologies and ensuring that you have a highly secure, highly robust platform. You need a central point of collaboration. It's important while there are sort of the separate worlds at times of the developers and the operation infrastructure team, and we can combine those in a DevOps kind of model, but they each do have some separate concerns, and there's a need that we have a platform that provides good situational awareness across that infrastructure. And when you add the multi-cloud environment into that, it's even more important that you have that visibility into what's happening on each of those clouds. And this also then, of course, ties into the importance of logging, monitoring, alerts, integration back into your ticketing system, and have the ability to gain that early awareness and visibility of issues that may occur. Flexibility is a core tenet and a core requirement for a great Kubernetes platform. We've talked obviously a lot today about multi-cloud and hybrid cloud environments. Choice of cloud is critical. You need to have that platform that can run on the appropriate infrastructure that meets your company and business's needs today and then what they may be tomorrow. That you can work across multiple infrastructures, but also multiple operating systems. Can you deploy your workloads on Linux and Windows host? And then also that it's extensible. The world's ever changing. The components that you're using today are certainly not going to be the components that you need tomorrow. Do you have the ability to swap out the networking component for one that's better suited to your particular application, the ingress component, the security aspects, having that flexibility to be able to change those components and provide you that extensibility is critical. And finally, future proofing. And it goes a bit hand in hand with that extensibility, that you can move your work, that you can use the components that are appropriate for your particular application needs today, but also that you're not being locked into any one vendor. Having a platform that's built at its core around open source technologies helps to address avoiding vendor lock-in. The ability to allow you to use sort of common proven technology that can be used across those various infrastructures, and really gives you that freedom to move and scale as you need. So Mirantis provides the Mirantis Kubernetes Engine, which fundamentally is about empowering choice for your Kubernetes deployments in your cloud native environment. We start at the core with your container workloads, right? And those fundamentally, your applications are going to be the most critical things and what differentiates you to the world. And what our goal is to simplify the rest of things around that so that you can spend your time and energies focusing on delivering differentiated value-based applications. Your container workloads will sit on top of a container runtime, and that can run either on a Linux or Windows-based host. And then from the management and the orchestration of your containers from Kubernetes, we provide both Kubernetes as well as the choice of Swarm. And we'll talk more about that in a moment. Really giving you a choice for what the right orchestration need is for your application. And then the network side and ingress components, we provide Calico for your networking and then Nginx for ingress, really giving you that flexibility, providing kind of an all-in-the-box solution for Kubernetes-based deployment, but as we'll see in a moment, the ability to change those out for your particular needs. We wrap around this areas of security. We have our Mirantis Secure Registry product, which gives the ability to have validation of your workloads against known vulnerabilities, and also a lot of control over what is actually deployed when, and if a workload can be deployed into your environment. And then rich capabilities around role-based access control and identity management, all the things that make it important or provide a solid, important security platform. So really all this comes together to give you a very flexible and powerful Kubernetes-based platform that enables you choice, running this on top of your choice of cloud environment, public, private, or hosted bare metal type solutions. Well, talking a bit more about the container flexibility. Again, it's a Mirantis Kubernetes Engine provides you both with Kubernetes and Swarm orchestrator choices. It really comes down to what is best for your applications and your environment. Kubernetes is great for very complex, highly scalable environments where you need a lot of power and a lot of flexibility and capability. But if you've got a small deployment, you're just making your way into the world of cloud native, perhaps that's a bit overkill, maybe a little daunting. So this is what we've seen it very important to continue to carry forward support for Swarm as an orchestrator, which works great in smaller scale deployments where you may not need all of that flexibility, all that power that Kubernetes can provide. You've got the ability with these choices, again, to run on Windows or Linux nodes, and then you can also bring your choice of role-based access control to the party, so to speak, as well, to give you that option. So again, yet another vector of choice that Mirantis provides with the Mirantis Kubernetes Engine. And we also provide then all the necessary dependencies out of the box. We mentioned at the forefront of the discussion how Kubernetes itself was not all that's needed. There's all the sort of supporting pieces and components that are required, the networking, the ingress that are necessary. We provide those to you pre-validated and functional so that you can really use this out of the box to deploy your workloads. And for the CNI, we provide Calico and really giving that flexibility for your networking. But should you wish to change that out for some other solution, you certainly have the capability to do that. It's a modular architecture that allows you to plug in your choice of components there. Likewise, for the ingress, built-in support for Nginx, so that you don't have to wait for someone to integrate that for you or bring that forward. But again, you have the ability to use other technologies, perhaps something from Aceto or others if you wish to do so. All right, so at this point, it's time to sort of see this in action, see Mirantis Kubernetes installed and running on Google Cloud Platform. And with that, I'm going to toss it over to my colleague. Renaud, do you want to take it over from here?
All right, thank you, Michael. I will go over over installing MKE on GCP. And part of that will cover some of the prerequisites that are needed for installing MKE, primary being Launchpad and Terraform. We'll go over provisioning infrastructure in GCP, and then install MKE. And then after that, I'll do a quick demo of a GCP cloud integration. So Mirantis has a tool called Mirantis Launchpad. Launchpad makes it very easy to install MKE and other Mirantis product onto public and private clouds. For example, AWS, Azure, GCP. It also provides some Terraform scripts, which can be a starting point for you to automate your infrastructure. So this the Launchpad is available at Mirantis on GitHub at Mirantis-Launchpad, and you can download Launchpad from here. There are also some Terraform scripts for various platforms like AWS, Azure, GCP, and these can be used again to provision infrastructure. There are also instructions on how to set up these scripts and provide credentials that are needed. Okay, so we will start by cloning this repository and then using GCP scripts to provision the infrastructure. I'll copy the link, the SSH link from here, and I'll switch to my console. On the right hand side is my console, and on the left are the commands that I'll use during this demo. I've already installed Launchpad and Terraform on this machine, so that is set up for me. Okay, so let's start by cloning the repository. And I'll just cd into the GCP Terraform scripts. These are the files that are available there. Most of the scripts are in the modules, and they're separated by separate modules. From here, what we can do is Terraform requires, in Terraform, you can set some of the variables using terraform.tfvar files. There is an example file here, so we can copy that file as a starting point for our Terraform variable files. So we can copy that, and we can open up the file. These are some of the variables that we can configure for our infrastructure. So let's rename this to say GCP demo, and I'm going to say we'll use one manager. We don't need any MSR for this demo. We'll use 2 worker nodes, and let's also change the default password. And another thing that I'm going to add is an MKE version. We'll set it to 3.6.0. That's basically it. There are other variables that can be configured, but for this example, these will suffice. And the next step, if you see on the left hand side of the screen, is Terraform init, which initialize the Terraform components. Then Terraform apply to actually create the infrastructure. And then there's an Terraform output command, which outputs a launchpad.yaml file. And this is the file that we'll use in the next step. There's also a handy script in here, which is run.sh, which basically runs all the Terraform related commands in one go. So we'll just use that. We'll just run that script. It's gonna initialize the Terraform, and then it's gonna create the infrastructure in GCP. So right now it is doing that. This is going to take a while, so I'll switch to my other terminal where this has already been done. So after you run that command, we have a file called launchpad.yaml in our so this is the file that we're talking about. And if I open that file, so the second tool that we will use is the Launchpad, and Launchpad uses launchpad.yaml to install MKE on all the nodes that are provided here. And you can also provide some install flags and other configuration for MKE. For this example, we'll edit this file and provide cloud provider equal GCE, which is the cloud provider for GCP. And I'm also going to set the version for MCR, which is the Mirantis Container Runtime. And I'm going to set that to the latest version, 2010.13. So this is the MCR version that will be installed on all these nodes. And 3.6 requires this particular version. So I'm going to set it to there. And that's about it. The next step is to install MKE, and Launchpad apply will do that. So if I run Launchpad apply here, it will start installing MKE on all the hosts that we have given. Again, this is going to take a while. So I'm going to switch to another screen where this step has been done. So after running Launchpad apply, it will give you the IP address for the MKE admin UI. So let's navigate to that. This is SSL error. For our demo cluster, we didn't set up proper SSL certificates. So this can take note now. 1, 2, 3, that's it. Okay. So this is an MKE cluster running on GCP. If we go to on the left-hand side, if you go to shared resources and the nodes, you will see all the nodes, the one manager and 3 worker nodes that we had. And MKE also lets you manage both Kubernetes and small SWORD workload. So that can be managed from here. You can create new resources for Kubernetes and manage other objects, and very similar for Swarm as well. And there's also access control from the access control menu, and which lets you make organizations user and assign roles to them. Okay, so and let's also quickly look at the GCP console as well. In here, you will see those 4 machines running, which was so these 4 machines from our final cluster. So when we ran our launchpad Terraform scripts, it basically created the whole infrastructure, including VPC machines, all the firewalls rules that are needed for GCP. Okay, so the next step is for me to demo a cloud integration. For that, I'm going to create Kubernetes objects. I'm going to create a deployment of a test application called HTTP bin, and then we'll create a service, Kubernetes service with type load balancer. So when we create a service of type load balancer in Kubernetes, Kubernetes will try to create an external load balancer on the cloud platform it's running on. So if the integration is working correctly, you would see a new load balancer being created in GCP targeting our service. So let's do that. I'm going to copy this the YAML content, and I'll use the MKE UI to sort of create these. So to do that, we can go to from the MKE console, we can go to Kubernetes and then create, and then copy paste the YAML content here. I will do that in the default namespace. Again, we're creating a service of type load balancer and a deployment. So when you create that, you created all 3 services. Going to the service tab, and you will see that we have this new service, HTTP bin.service of that load balancer. There's no external IP here, but let's go to Google console and navigate to VPC network, network services and load balancing. And you will see there's a new load balancer here. And if you open that load balancer, it's targeting all our 4 nodes, and there's a public IP address for this. Let's switch back to MKE UI. I'm going to hit refresh here. And you would see the same IP address is now showing up here. So that has been set up properly. And if we navigate to this IP address, we'll see our HTTP bin service running from within our cluster. So basically, yeah, that was the demo of creating infrastructure in GCP, installing MKE on top of it, and then a cloud integration, a deeper cloud integration for Google. One thing that we can do is if we actually delete this service, and the corresponding load balancer should also be deleted from GCP. And this takes a while, but it takes a few seconds, but it should delete from there. That is the demo of what I wanted to show you.
Great, thanks, Vinod. Great demo there, and to see how easy it is to get Mirantis Kubernetes Engine running on top of Google Cloud Platform, and very similar process for doing that on any of the other cloud providers as well. Really powerful tool to provide a generally accessible Kubernetes platform on your platform of choice. So as we kind of conclude here today, just wanted to reiterate and touch on a few points about the Mirantis Kubernetes Engine offering. What we're providing to you is a production-grade, enterprise-ready platform that's allowing you to deploy your containers on your choice of infrastructure workloads. Provides you with easy onboarding, provides you a single point of collaboration, rapid development management updates, delivers continuous compliance when used in conjunction with Mirantis Secure Registry. It provides you security across a variety of environments, helps you avoid that vendor lock-in of being tied into one particular cloud provider's Kubernetes services or other cloud services. And finally, and most importantly, let you run your apps where you want, when you want, as needed. And with that, I'd like to just kind of finalize to highlight other areas where Mirantis may be able to help you in your cloud native journey. We offer a number of products that are intended to really build out your cloud native infrastructure, starting with the Mirantis Container Cloud, providing a single pane of glass visibility across all of your cloud deployments. The Mirantis Kubernetes Engine, as we've discussed today. We also have a product called Mirantis OpenStack for Kubernetes, which allows you to deploy your virtualization-based workloads on-prem, but take advantage of Kubernetes and the power that that brings in terms of resiliency and availability. We also have tools such as Lens, Stacklight, and others to provide visibility into your offerings. We couple that with support offerings, our OpsCare and OpsCare Plus offerings that provide self-care and managed service. And then we also have a rich team of professional services experts that really are Kubernetes and OpenStack and cloud native experts that can help you rapidly move faster on your cloud native journey. And we wrap all of that up together with training, the capability to provide your team with Kubernetes and OpenStack training, both at a technology level as well as a product level, that we can help you really speed up and ramp up and level up your team's cloud native knowledge. And with that, we're going to kick it over to Scott for some Q&A.
Okay, excellent. Well, Mike, great overview of the issues around vendor lock-in with Kubernetes and how the advantages of portability and security and management with Mirantis work out there. And Renaud, really valuable demo of the nuts and bolts of what Mirantis looks like there from the operational side. So we do have some questions coming in here. The first one, they're asking, I'm currently running workloads on a single public cloud provider, and moving to another provider would be difficult due to using specific APIs and services from this provider. So how would MKE help me here? So I guess, Mike, maybe that's a good one for you.
Yeah, I'll take that one. So I think fundamentally, I think that's one of the challenges that we're looking to help you solve with the Mirantis offerings. It's very easy to get locked into a particular cloud provider's services. Some of the providers provide just an enormous set of capabilities and services, and before you know it, your applications can just be intimately and tightly ingrained into that particular provider, making it very tough to move out of that. Our view is that, as we've discussed today, that you need to keep an environment where you enable choice and flexibility for your organization. So while you may be slightly locked in or feel like you may be a little locked into a particular provider today, we'd recommend talking with you about how Mirantis' team can help you lift and shift, if you will, your workloads from that particular provider's cloud native tool set, Kubernetes and otherwise, and move it over to a Mirantis-based offering that then would provide you a foundation and a platform to allow you to very easily run and deploy those workloads across the cloud native, the cloud platform of choice, whether that be Amazon, Google, Azure, Equinix bare metal, or of course locally bare metal on-prem as well.
Okay, all right, super. This next one is probably best for Renaud. What happens if you don't enable cloud integration? Does MKE still work on GCP?
Yes, actually. So in this example, we enabled cloud integration by providing install time arguments called cloud provider equal to GCE. That is actually not required. That is to enable deeper integration with the cloud provider. But MKE will run on GCP or AWS without the cloud integration. And that can also be enabled or disabled later as well. It doesn't have to be installed time. It could be configured at a later time as well. Would just mean that if you don't have it enabled, you wouldn't have the load balancer in this example being automatically created, for example.
Okay, excellent. Thank you. Next question. When might I want to run Swarm versus Kubernetes as my orchestrator?
That's a great question. I think Kubernetes, as we mentioned earlier, Kubernetes has received so much attention and really is in many ways viewed as the de facto orchestration technology for containers. But there definitely are environments and scenarios where it may be a bit overkill or a bit much. It is a very complex orchestration tool, and there's a lot going on, a lot of power that comes with that. But for companies that are earlier in their cloud native deployment, or maybe just don't have a very large scale deployment they need to tackle, orchestrator like Swarm is perhaps a very viable and maybe arguably a better choice for their particular needs. When Mirantis acquired the Docker Enterprise business, roughly approaching 3 years ago, I guess now, it was a very important aspect for us to continue forward maintaining and developing and enhancing the Swarm technology that came along with that acquisition. We have quite a number of customers using Swarm today still, and we continue to invest in that technology to make sure it moves forward and solves the needs of customers that may just not need to take advantage of the full power of Kubernetes.
Great. Next question for how do you handle ingress traffic in MKE? Renaud, any thoughts on that one?
Yep, I'll take that one. For ingress, MKE actually provides you a turnkey solution for enabling ingress for both Swarm and Kubernetes. From the MKE console, you can just enable ingress and also configure it from there. For Kubernetes, we use Kubernetes native ingress resource. So you can specify your ingress using Kubernetes resources and have it and have your apps being exposed via ingress controller. If you have a deeper cloud integration enabled, it also you can also create an external load balancer, which makes it even easier for you to expose your applications externally.
Okay, great. This one they're asking, I use a public cloud today for parts of my business and would have the benefit of moving certain cloud native workloads to GCP, but I still need to be able to run specific workloads on-prem. How would Mirantis help me here?
That's a great point. I think that's something that we see increasingly having discussions with existing and potential customers around that need. Early, as we did talk about this a little earlier, the cloud is a great platform to innovate and move fast and experiment and do early deployments around. It gives you that flexibility to ramp and scale things up that without having to go procure infrastructure, on-prem infrastructure equipment and deal with lead times and servers and racks and cabling and cooling and all those types of things. However, at some point when you reach a bit of a steady state or at least a predictable growth path, it may make sense to bring that back on-prem, where you can have more direct control over your costs and you're not paying for that flexibility premium, if you will. So the benefit that MKE provides is it does provide you a single interface, single mechanisms to deploy your cloud native workloads, container-based workloads across your choice of those platforms. So if you're on Google Cloud today or on Azure today, you can then bring and repatriate, if you will, those applications back on-prem, or decide what the right mix and match of those workloads are. Cloud native environment applications, you're going to very likely containerize your application to microservices, and you may wish to run certain portions of your application on-prem. Maybe things that are holding and warehousing user data or other security and critical components, but then have some of the front end application or web-based application or other front end user components that would be running in cloud, perhaps closer to the actual user for speed and latency purposes. So it really gives you that flexibility to choose and mix and match what's best for your particular environment without putting any specific constraints upon you.
Okay, super. Well, unfortunately, I think we're probably going to have to leave it there. But, Mike, if somebody wanted to get started with Mirantis, in MKE, what would you recommend?
Yeah, well, we certainly welcome you to visit our website at www.mirantis.com. A couple of resources I'd specifically point you to. One, we do have a relatively recent blog article that talks about the topic exactly today of installing MKE on top of Google Cloud Platform. So if you'd like to sort of try and replicate what has been done today, certainly take a look at that. We also welcome you to give a try with our free trials. There's a trial for Mirantis Kubernetes Engine as well as our other products. If you wish to sort of do so in a hosted environment, you can maybe take it a level up and take advantage of the Mirantis Container Cloud environment and the trial there, which has a hosted platform on top of Equinix Metal, and really can give you that full cloud native experience using Mirantis. So we encourage you to take advantage of those and certainly reach out to us for any additional questions.
Okay, super. Well, Mike, Renaud, thank you so much for coming on today and bringing us up to speed on sort of the state of Kubernetes and on what Mirantis is doing to help people with it. Appreciate it.
Thanks, Scott. Thanks, everyone, for joining us today.
Thanks, Scott.